ya, back split ya. Fuck fist fights and lame scuffles. Pillowcase to your face, make the shell muffle. Shoot your daughter in the calf muscle. Fuck a tussle.
Alright, so just an overview. Our definition, the two that we've learned, definition of the derivative, definitions of the derivative. Okay, so this is what we know. There are two ways. The first one is going to be f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a and then all over h. So that's the second one we learned. And then this is also equal to limit as x approaches a of f of x minus f of a over x minus a. So this was the second one we learned, and this was the first one that we just learned. Okay? Alright, so that's just a refresher there, and now we'll go on to something a little bit different, but uses the slope of the tangent line. So what we're going to do is find the equation, so I'll write equation there, equation of the tangent line, of the tangent line. Okay? Alright, so what is this going to look like? So basically, again, I'll draw a little quick sketch of our graph here. Okay, so let's say this is our point P, and this is the tangent line itself. Okay, so what is this? What's the formula for this tangent line? So here's point A, and that's f of A. So point P itself is A, comma, f of A, and we just found that the slope of the tangent line is basically the slope of the secant line as the second point gets closer and closer and closer to P, right? As Q gets closer to P. And anyways, so the slope of the tangent line is going to equal, it's just denoted f prime of A. That's the first derivative, right? Evaluated at A. Okay, so how do we construct this? Then the equation of the tangent line in point slope form. So I'll just write it like this because that's pretty convenient. So point slope form, because we have a point and a slope, so that's good, we can use it. So it's going to be y minus the y value of our point, so f of a, is equal to the slope, so that would be f prime of a, and then multiplied times x minus the x value of our point, which is an a. Okay? So this is going to be the equation for our tangent line. So when a question asks you for an equation of a tangent line, all you have to find is a point on that line, and then the slope of at that point, okay? Or the slope of the tangent line at that point, okay? All right. So now let's do a practice problem. So what if we are asked to compute f prime of 2, where f of x is the following function. If we have an x squared minus a 3x, okay? So on this problem, our a equals 2, okay? And let's actually just use what we want. I'll use the second definition of the derivative. So limit as h approaches 0 of f of a plus h minus f of a all over an h, okay? So what we want is limit as h approaches 0, and I'll plug in 2 for a now. So we want f of 2 plus h minus f of 2 all over h. Okay, so right now, all we have to do is basically plug in this value, find out what is the function evaluated at 2 plus h, and what is the value of the function evaluated at 2. And then we'll plug them in and see how we can simplify that limit and evaluate for it. So what is f of 2 plus h? What does that even mean? That just means since 2 plus h is in the x spot here, we just plug in 2 plus h wherever we see an x, okay? So we're going to plug in a 2 plus h in for the x spot, so that'll be squared according to the function, the given formula, minus a 3 times x, but x is now 2 plus h, so we're going to plug that guy in. Okay, so then we'll just continue solving for this, alright? So we're going to get a 4 plus h squared plus 4h, okay? And then we get a minus 6 minus 3h. So this turns out to be, what are we going to have? An h squared, and then a plus 1h, and a minus 2. Okay? So that's what we have for the first box. Alright, that's our f of 2 plus h. And now let's solve for f of 2. That should be a little bit simpler here. So we're going to plug in a 2 for x. So 2 squared minus 3 times 2. So that's going to be a 4 minus a 6, which is a negative 2. Okay, so now we found the second box there. So we're going to plug in a negative 2 here. All right, so I'll continue this on the next slide, setting up our limit. All right. Okay, so now limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. That's going to be the following. We're going to have limit as h approaches 0 of h squared plus h minus 2. So that's the first, that's our f of 2 plus h. And then we're going to subtract, so minus our f of 2. So that was a negative 2, all right? So then we have all of that over h, okay? And up here we can simplify because these two negatives turn into positives. So then we have a negative 2 plus a 2, so those cancel out, right? And we can simplify this to limit as h goes to 0 of h squared plus h over h. And now we can factor out an h from the top. So limit as h goes to 0 of h times h plus 1. And this is an over an h. So then here we see that we can cancel, which is good, because otherwise we would have had a 0 on the bottom, and that limit would have been undefined. But here we removed this indeterminacy. So now we're left with limit as h goes to 0 of h plus 1, and we can simply plug in the 0 for the h, so 0 plus 1, and this is going to end up being a 1 overall. Okay, and this, again, this was equal to f prime of 2. So given that our f of x was x squared minus 3x, and 2 was our a. Okay, so this is the slope of the tangent line of our function at x equals 2. Alright, so now I want to go over the derivative of a linear function. Derivative of linear functions. Okay, and linear meaning looking like a line. So lines, in general, they have the form of f of x is equal to, or you could even say y, f of x or y is equal to mx plus b, where b is your y-intercept, so b is just a constant. This is just a constant, okay? And m is your slope, all right? So we should be familiar with this, I hope so. And anyways, so what we're going to say is that f prime of a, okay, so we're going to start by just with the definition of the derivative that we know. I'll use the second one, the h one, because that's the most commonly used one. So limit as h goes to 0 of f of a plus h minus f of a over h. So this is the definition of the derivative, and now let's apply it to this linear function, this general form of the linear function. Okay, so what if we were to plug in, let's see here, how are we going to do this? So limit as h goes to 0, and this time we're going to use the top thing that I circled, so that function, that linear function, as our function, as our general function. So if we're going to plug in a plus h in for the x spot, this is what we're going to do. So we'll have this function, so mx plus b, right, that's our function, but now our x is going to be an a plus h, and then we have our plus b. Okay, do you see that? So we just plugged in a plus h in for the x spot here, all right? And so that's our f of a plus h if we're using the linear function. this is kind of like a proof, sort of, but it's pretty important to understand where this comes from. So then we're going to subtract f of a. Okay, so we're going to write down our function again, our linear function, m of x plus b, and in for the x spot, we're going to substitute in an a there, okay, because we're evaluating at a. And then this is all over just h. H just hangs out there, okay? All right, so I'm going to continue this on the next slide. All right, so now what we have is a limit as h goes to 0 still of, if we distribute the we get ma plus mh plus b. Okay, so that's for our first term there, our f of a plus h. And then this is subtracting m times a plus b. That was our f of a alone. And then we have an h on the bottom. Okay, so let's see what we can simplify here. This is going to be equal to limit as h goes to 0 of ma plus mh plus b minus an ma minus a b. and this is all over h. Okay, so we see here that a positive MA cancels out with a negative MA, a positive B cancels out with a negative B, and all we're left with is limit as h goes to 0 of mh over h, and we see that an h cancels out from the top and bottom, so we just get that the limit as h goes to 0 of m, and m is just a constant, that means the slope of our linear function, so we're just going to get m. Okay, so we've reached an important conclusion so this is our f prime of a, that's the slope at any given point on our line. So if, here I'll write the conclusion down here, so if our f of x is some kind of linear function, therefore it has the form mx plus b, so if this is a linear function, so that just means a line, right? So is a linear function, then f prime of a, so the derivative at every point, so the derivative for all a is going to equal m, just the slope of your line already. Okay, so that's our important conclusion at the bottom there. And now I have one more thing that I'd like to go over, and that is the derivative of a constant function. So derivative of constant functions. And don't worry, this is going to be a lot easier than linear functions, okay? So a constant function just means that you have some kind of like y, or f of x is equal to a constant. So this is just like a number, right? Like 2 or 3 or something like that. So what we have is basically, so here's our x and y, and a constant function would be like y equals 2. So then you have a line going horizontally across. This is the line y equals 2, or f of x equals 2. Okay, so a constant function like that. It just stays level. All right, so let's see what happens here. So we're going to use our definition of the derivative. So I'll rewrite that here. Okay, limit as h goes to 0 of f of a plus h minus f of a over h. Okay, so if we were to plug in a plus h into our function above, into this one, into our constant function, this is what we would get. Limit as h goes to 0 of f of a plus h. So there's really, we don't see an x here in the formula, so we're just going to write that constant there, because the constant function is, no matter what the x value is, we're still going to have this value, so of 2 or of c here. Okay, so then minus, if we plug in an a, that doesn't really matter wherever that is on the x-axis, we're also going to get a c out. Okay, and then over h, so this will turn out to be limit as h goes to 0 of 0 over h, and that'll just be a big 0 there. Okay, so our conclusion for this one is going to be that if f of x equals c is a constant function, okay, constant function meaning it doesn't change in the value or the output no matter what the x is, what the x value is. If this is a constant function, then f prime of a is going to equal 0 for all a, Okay, so that's another important thing to remember. All right, that concludes our definition of the derivative video. I hope that helps, and good luck on your homework.
Crazy, think a little bit of rhymes can play me. I'm from Mars, see I'm varsity champ, your JV.
Trigger
Jay-Z.
Nigga, baby, my bed style flows malicious, delicious. Fuck 3 wishes, made my road to